Thank you, Chairman, and thank you for giving me this opportunity. What I will do is next 5-7 minutes is just to tell you the more and more we are working with farmers last 4 years, more and more we find that very latest technologies have applications, and you will see some of those and which we are trying out, and I'll highlight some of our experiences. Now, when you look at a farmer in the center, he has not just agro-advisory. Yes, that is necessary, but he has many more things. There are poultry and cattle and micro region weather forecast, which he mentioned, Dr. Chattopadhyay, best practices, procurement, crop insurance, primary health care, etc., etc. So, he requires integrated services. He requires personalized services. So, the challenge, I think, is how do you build a platform? How do you build a software, which integrates all these services and which it can be scaled up. So when millions and millions of farmers can can be addressed, different business models can be addressed, because stakeholders of farmers are very many. So platform challenge is there. Then personalization challenge. I think you see that with this specific person is asking a question and you have to advise him very specifically. So how you can do personalization with so many people, so many farmers are there, because for them their problem is important. So depending on their soil, operation, farming operation, etc., you got to address that, just like doctor addresses the patient. Then another thing is that can we reduce the pesticide spray? If we can predict the diseases, I think the prevention can be done. Now, fortunately, there is a lot of work that is happening to build the models to predict the diseases, and we found that there is a way to combine IT, computer science with agriculture. So this can be done much better way. So mathematical model with human observations, you can combine that, and it can do pretty good job, because when models say that yes, there is a risk of disease, then immediately I think the application should ask few questions to farmers, ask farmers to upload some of the pictures, and that way human observation and mathematical models can be combined to increase the confidence level of these diseases. So that's another. Of course, there is a yield prediction, and there are many such models. Then end-to-end system. Here is a farmer remote in a village, some literate, some semi-literate, some illiterate, and how you can have end-to-end system. They are asking a question, you are responding to them in what a service they want and in a personalized way. So that's also a challenge, because there are multiple components involved. So how you integrate those? Of course, the user interface is very, very important. I think the usability is very critical, and that is where you got to combine whatever makes sense. Sometimes farmers are very comfortable asking question in voice, let him do that. Sometimes he doesn't mind scrolling and clicking, let him do that. So I think that aspect is very important, user interface. Of course, Indian languages, many people said, poses a lot of challenges. Yes, they do. Of course, we have all kinds of handsets, so sometimes some of these things will not work. So that time you have to go back to some other technology. But don't let those farmers say that you cannot receive those services. The other technology could be like IVR type of technology can be integrated with the platform. Some of the things which may not come now but may come very soon is that handwritten. And if you can recognize handwritten, a lot of transactions can be done from this. So handwritten recognition for Indian languages is another technology which is very important but tough. But I think in a particular domain a specific thing, it may work. Third, I think the speech recognition, though this technology overseas has been there for last 10, 15 years, in India it's just not making progress. I mean, few words here and there is fine, but if farmer picks up a phone and asks question in his own accent and language, none of the systems work in India. I think that is very critical. I think this particular technology is most, I mean, it is required by in India the most, because that is where gives the power. Well, customization challenge, because you have multiple crops, you have multiple views, multiple experts, multiple information coming in, and how you can customize that very, very quickly, because you got to have that integrated view of a farmer to give advice. So that is another challenge, which social networking, which was mentioned by earlier speaker. Now this is where the experiment we are doing, and it's amazing. I think this is 12 farmers in this Nera village near Mumbai. They are using this. One farmer is a progressive farmer with master's degree in agriculture. One dealer is also involved, and one agriculture people. They were anyway known to each other. So these 15 people use this very effectively. As I was saying, this wireless sensor node technology is a new technology, which actually, if you look at one sensor node communicates to another, that node communicates with another, such a network is formed automatically. And we believe that Indian agriculture has tremendous, it will make tremendous impact, because you can get a soil moisture map, you can get soil nutrient map, all of those dynamic maps can be generated by this. Of course, we have to wait till it becomes as cheap as 500 to 1,000 rupees an acre or something. Then this is for research. You see a lot of different varieties can be used, and some of these sensors we have put for grapes. Of course, those are for scientists who can use this, how the food comes from top and water goes from bottom, etc., etc. They study that sap flow. Remote maintenance and monitoring becomes important when you're going to put all kinds of weather station and sensors, etc. One should be able to click that thing in a map and should get that. And this is not just that only for the electronics, but it is also for the yield, the pesticide usage, the fertilizer usage. I think one should be able to see that on the map, so that you can, the supply chain. You can make the supply chain effective. There should be a way to do the soil nutrient mapping. Today's things are very clumsy. Somebody comes, picks up the soil, goes to the lab, the report is generated. Farmers are also not believing some of the testing centers. So I think the soil is collected from only 4 or 5 places in a farm, and we found that it's really not that way. I mean, that it varies, and it's very, very important. That's why some cases farmers find that there is a disease prone area, and in the same field other plants are very healthy. I think sometimes this, whatever that zinc or potassium or some micronutrient varies. So we are testing some of the sensors there, how you can generate these soil nutrient maps very, very quickly. There are many other things which I haven't put here, but just to give a flavor. See, we of course don't understand farmer, we don't understand agriculture, but when we started looking at a problem and try to give a solution, I think we have to take, we have to find out the very latest technology. And as I mentioned, that simple technology like speech recognition, let farmer talk and recognize that farmer, is still not there. And that is mostly, very quickly needed. So that completes my presentation.
Showing some aggregate parameters.
Yeah.
So I'm wondering if that is already functional?
Yes, it is functioning.
For which geography?
Yeah, it is functioning for weather stations and sensors. So you click there and you start seeing all those parameters, pressure, temperature, humidity, wind speed, you name it. And you see that you can see that.
Okay, thank you.
Okay.
Yeah.
Thank you.
The wireless sensor network.
No, see the business models, I think there are many interesting business models are possible, and all of these is certainly affordable. We have seen that. And see, all these things are not required for every crop. See, the crops like vegetables, fruits, etc., and doesn't have to be in each farm. See, it has an area, let's say 5 to 7 kilometers, things don't change much. So if it is 150 square kilometer, 500 farmers, I think 1,000 rupee a farmer somehow. And anyway, there are some ways of, if you put electronics, 50% subsidy is already there. And there are ways, I think, because many people want to reach farmer with half the cost. So there are many business models. One doesn't have to worry about that.
Okay, thank you, Doctor.
Yeah.